so this is the last session and last presentation, and I'm going to talk about a very small explorative research of part of my research in Cambridge. So I'm Jinying, and I'm currently a Mary Scott Curry Fellow at the Department of Engineering, University of Cambridge. So I would like to start with by quoting the problem statement from the Building Smart Sustainable Strategic Group. So they have nicely summarized the problems they are facing about digitalization and sustainability. So limited, robust solution, integration challenges, and lack of awareness of the data, and the data quality issues as well as low standardization. So I think the first, second, and the fourth problems are shared by many different application areas, but the third and the fifth, lack of awareness and low standardization, might be a little bit more unique to the sustainability. So my research is especially focusing on carbon, and is trying to increase the carbon data trustworthiness by standardize the carbon data collection methodology. So there was a framework that we developed about carbon data trustworthiness that we presented in the EC3 CIB W78 2 years ago. And last year in CIB W78, we tried to continue to work on the information requirements over the asset lifecycle to include carbon into digital twin. And then we also have another paper about the carbon data requirements from and how it is related in the standards. So this paper is more like an extension of those research. So in the carbon data trustworthiness guidance framework, we kind of proposed how we can increase the data availability, quality, compatibility, and security. And especially, we think a key part of it is to standardize the data structure. So to do that, we try to use the standardized data structure that we are using, especially the OpenBIM. And this is what the Building Smart Sustainable group have developed for their IDS. So they kind of divided the IDS into three key parts: the facility, product, and the declaration. To be honest, the declaration is also more about product because it's more about the EPD, environmental product declaration. And acknowledging that so this IDS, the Building Smart developed, is more for the design and for the inclusion of the embodied carbon. While when we really when we really collect the actual carbon emissions, we should not just consider the products or the materials, but also we need to consider the processes. And so that is where the fuels and the electricity comes from, and also so the product would come from material, essentially, the raw materials, and they would have EPD, and thus include the declaration. And also another part of it is the users. The emission from the user is a very big part for the infrastructure, especially for like road and other infrastructure. So my work was trying to kind of automate the carbon data collection process by developing a comprehensive ontology by integrating the material ontology and the asset ontology. Material ontology is about what types of material are there, and what are the relationships, and what are the embodied, like the types and also the quantities. And the asset ontology is about how these all different parts, the materials, products, processes all come together to form the product. And we want to integrate that as a comprehensive carbon data ontology. So we were thinking how we can include the carbon data in a digital twin. Currently, there is like in the IFC road, you can see that there are different levels of IFC entities, including IFC road, facility, and others. But in the property set, you could not find like very direct carbon-related properties. So what I was trying to do is very simple, just to try to kind of map out what the existing IFC data entities are there that is relevant to carbon. And then if there is not carbon-related properties, we then extend and define the properties. So this is how kind of we map that. At the top level, we would have the project, because we care. That's in the infrastructure sector. That's more like what we do with a unit using like a project, and they would come from maybe different parts of the road, and in road maybe different roads adding together to a project, and then there are different road parts, and the road parts you have different road segments and different element parts. This is just a partial view of it. And also then the IFC processes and the resources would be would be part of it that come to be the road part. So then the resources, you would have different types of resources that are also relevant to the carbon. And also we try to find something about the user carbon, but I think the IFC actor, that is something we can extend the definition to include the user emission. So and then this would be the data flow, how we are going to start with how much energy, material, and water we use, and then how they go through the process and the resources, and then different parts of the road, and then to the end of like a project, and even finally an asset. So that is a simple data flow following the IFC standards. And more importantly, it's the key property set that we try to extend. So as you can see, those underlined are the new property set that we developed, while the others are the existing the property sets that's already there. So by doing this, we can then include the carbon relevant property sets into the digital twin. And also we try to maximize or try to use what is there as much as possible. Like for example, if for the resources, we can use the quantities and also the different types of quantity construction resources and all that as much as possible. And we did the test based on a very small road IFC model that is provided to us from Mr. Nicholas Nibisset. And so we tested that by kind of included that those different carbon relevant data in it, and do like a query of how much emission it would have. And it's very simple. It's easy that you can automatically do the calculation, so that you know how much emission should be like embodied in the road section from both like its material and also its processes, stuff like that. So you need to when you define the objects, you need to have the processes, which is maybe not quite there when we do the modeling. But if we have the digital twin or more like real-time updated BIM or digital twin model, then it is not a problem. So technically, this is very easy and simple, and that's how we can include carbon into digital twin. So that's one kind of like the technical kind of proposal of that. And so that concludes my presentation. And yeah, so I would like to thank the funding that is coming from the European Union's Horizon 2020 project. And so if you'd like to contact for research about this, or so I'm focusing more on digitalization and for project sustainability, construction project for sustainability. And just a slight note that I'm going to change jobs, so there are different email addresses that I can use. Thank you.
Thank you very much.